What's going on, guys? In this episode, I want to talk about how are the products that we use every day safety assessed. The principle behind determining the safety of every product that's put on a shelf of a supermarket is basically the same. And that's what I'm going to go through today by taking the example of cosmetics. There are a few assumptions that we make when it comes to cosmetics that are quite different from other products, but I'm not going to go into the nitty-gritty. Let's talk about principles and the basic way of risk assessing any product at all. So let's have a look at these products and talk about how a safety assessment might be done for each of these. First off, it's quite easy to find out where these products are applied in the human body. So for a shampoo, it's obviously usually going to be applied to your hair. A hand wash is usually going to be used on the hands. Another quick thing that we can say about all of these products is whether they're going to be washed off or left on the body after putting it on. So a shampoo is most likely going to be washed off. At least that's the intended way of use. Toothpaste is going to be rinsed out of your mouth. A hair product is most likely going to be left on for most of the day. Now, this is qualitative information. How do we translate this into quantitative information that we can plug into calculations to find out if the product is safe or not? And there are studies that show the surface area of the head, of your hands, of your whole body. So we can use that information to find out how much surface area these products will be applied to. So for a shampoo, that's about 1440 centimeters square. For a hand wash, it's the surface area of your hands. So we would do a risk assessment for a toothpaste in a different way, and we don't need that centimeter square information. So we're going to make an assumption here that a hair product is used on half of your head and half of your hands. Now, a cream that specifically says apply it to any part of your body, we can say that like a body lotion, it's going to be applied to your whole body. And if that is the case, then we're going to take the whole surface area of your body. And an underarm deodorant, since it's probably used only in the underarm, we're going to take the surface area of the underarm, and that's about. Now, we can also make another assumption regarding the products that are washed off. So let's say that only about 1% of a product that's washed off from your body is actually left on at the end of that washing process. For a toothpaste, we're going to assume 5% of the toothpaste is ingested. Since a hair product is left on, we're going to go for 100% of that product is left on. So we haven't talked about how much is actually applied per application. And that information, again, we can get from study data. You might have noticed there's an issue here. All of those products that we talked about before, I don't have the formulation details for. And even if I did, I most likely couldn't speak about that online. If I did, I'd probably get sued. And I don't want to get sued. So I'm going to pick a formulation from the internet and we're going to roll with that. Pick any cosmetic product, look at the label, and you'll realize there are tons of ingredients that go into making any cosmetic product on the market. There are things like fragrances, humectants, those are moisturizers for you and me, water and oil and acids and alcohols, and all of these compounds need to be risk assessed before a product hits the shelf. We don't have the time for that, so we're just going to pick something from a product that I found online. So this is a type of formulation that would go into something like a face cream. So this is an Aveeno cream, and if you look on the back label, and specifically this part, you'll notice there's mention of many ingredients. You'll notice some of the first ingredients are aqua, glycerin, something I can't pronounce, and paraffinum liquidum. And all of these things are in a certain order. So the regulation in the EU states that anything above 1% in a cosmetic product needs to be listed in a decreasing order. But just by quickly glancing at this product, we can tell that most of it is water. The second largest component is glycerin. And another thing to keep in mind is that various companies will list ingredients in different ways. So on this Aveeno body lotion, I've got something called paraffinum liquidum, which on my face cream, I've got something called mineral oil, and they're exactly the same thing. Another thing in this Aveeno lotion that I just noticed is something called Avena sativa kernel flour. That just means oat kernel flour. So anyway, let's pick any one of these ingredients. Let's say glycerin is present in your face cream at 30%. So if glycerin is present at 30% in your face cream, how much is a person exposed to per day? Well, what we do know from study data is that face creams are used at around 1.5 grams per day on average. So we can use that number in this calculation. 30% of 1.5 grams per day we get 0.45 grams per day. So there's no need to make any more adjustments with retention factor because a skin cream isn't washed off your face. It's usually just kept on. Now, another thing to keep in mind is absorption. So let's say around 50% of that glycerin that a person applies on their skin every day is absorbed into their bloodstream. 0.225 grams of glycerin in the circulation per day, equivalent to 225 milligrams per day. Now we need to know what exposure leads to bad consequences. In any risk assessment, you need to look at hazard and exposure. So at this point, we could refer to a rat study and look at what glycerin does at various doses when it's given to a rat, either orally or dermally. Now, I know this whole thing about animal studies and nobody likes animal studies, but the thing is, animal studies are really difficult to avoid when doing a risk assessment. Most of these ingredients that are in cosmetic products have already been tested. If you look at any cosmetic product, you'll realize most of these ingredients are the same. In cosmetics, although animal testing is banned, in pharmaceuticals it's not. So a lot of ingredients might have been tested for pharma, but you might be able to use that study information for a cosmetic product. Cheeky, I know. So there's another really critical part of our risk assessment, and that's something called a NOEL. And a NOEL is a no observed adverse effect level. It's shortened for NOEL for obvious reasons, and it basically means at that rate, when administered to a rat, no harmful effects that resulted from that glycerin was seen in the rat. And this value, called the NOEL, is one of the most important parts of our risk assessment. I'm going to talk about what you would do once you have that NOEL value. So let's assume here that you derived a NOEL value of about 1000 milligram per kilogram body weight per day. You might have noticed our exposure value was in milligram per day. So to make sure we have the same numbers, we need to divide this number by an average body weight of a human. So let's say in this case, we're looking at a 60 kilogram user of our product. So that's about 3.75 mg per kg body weight per day. So now we know what doesn't cause an adverse effect in a rat, and we know what the exposure is going to be for a human being. If you do 1000 divided by 3.75, we get 267. And that number is our margin of exposure, or MOE. And the margin of exposure in a single number shows us the difference between the number that doesn't cause an effect or an adverse effect in a rat and the number that shows the exposure in our user. So the greater the margin of exposure, the more confident you can be that your ingredient isn't going to cause anything harmful in a user. Almost any ingredient in the world that you look at can kill you if you give too much of it. So if you know that any ingredient that goes into a cosmetic product can kill a human being, you want to know what is the safe level. What's the safe level in an animal that we've tested it in? And what's the exposure in a human being? And this difference between a safe level in a rat and the actual exposure in a human, we want to be the greatest possible. In general, or speaking legally, if something is over 100, then that's generally considered to be safe. Now, if you're looking at something like a carcinogenic product, then you would want that number to be very high, around even 1000. A lot of preservatives, for example, can cause a lot of health issues, but when used at low enough levels in a human, the threats of this happening are minimized. So you can be more confident the lower the level is. It's the dose that makes the poison. Now, other products that we use every day will have been risk assessed using similar principles like this one. Now, this assessment that we did can be used for things like carcinogenicity risk assessments that you would do just to make sure that your product doesn't cause cancer. There are also other parts of a risk assessment like genotoxicity or genetic toxicity, where you would check if something is going to cause direct mutation to your DNA. A type 4 allergy risk assessment where you would check if something is going to cause sensitization in a person, whereby a certain person would elicit a reaction to that ingredient for the rest of their life. Again, really important parts of a risk assessment, but done in a slightly different way. Also, risk assessments also involve things like irritation, reprotoxicity, and a whole bunch of things. Let me know if you have any questions in the comment section below, and hit the subscribe button if you want to watch videos like these in the future. I'm Roshan Patel. I'll see you next time. So what differentiates these products? Man, I'm making a mess.